All right, let's do example number 8. I believe this is the last example from our text.
Yeah.
Yep. Oh, no, there's number 9, but
Don't care.
future values is what example number 8 is about. So Mr. Adams has always tried to explain to you guys, usually in math, we use math for 2 things, science and economics, especially this type of math, right? So this one's used for economics a lot, right? So we have a formula, and it's based on interest rate. The future value of an annuity, which is like a savings account, it's very much like the interest rate on a credit card, but on a savings account or an annuity, it's compounded on a regular interval, it's periodic, and you start off with an initial investment, and then you can determine how much time you want to put it in. So like a certificate of deposit or a CD is usually what it refers to, and there's other types of annuities. But the formula is this, it's the future value is equal to R, and that's R is really the dollars that you invest. I don't and it's so N is let's explain the formula stuff. There's going to be some stuff you're going to see. The future value of an annuity consisting of N, and that's the equal periodic payments, and R is of dollars, and I is the interest rate. So it's kind of the same setup, just different letters representing different things. And that's per compounding period, and it's a payment interval. And so the formula is R times 1 plus I raised to the n minus 1 all over I. Now technically what annuities are is you put money in a savings account and you leave it in there for a long time. And as it accumulates over time, it bears interest. And if you bear enough interest and you have enough money in there, the payment that you receive is based on the interest that you've earned. Does that make sense? And so this is the formula to determine the future value of an annuity. So let me read the example. It says, at the end of each quarter, Emily makes a $500 payment into a mutual fund. If her investment earns 7.88%. So that would be I in this case, which is a little different, but it says that she pays $500 and she has an interest rate of 7.88, which would be 0.0788 as a decimal. And it's compounded quarterly. 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 What does quarterly mean? It's kind of like k equals 4, but the formula doesn't have k in it, so I'll show you how we do that in a second. And then it says over 20 years. Okay? Now the only thing I don't like, and this is what I want you to write down, is when you see this formula, is there a place for k? Is there a place for the number of years? No. So we've got to figure that out together. Okay? So the interest rate is really this divided by 4. Right? And then n, which was the number of payments, n is really 20 times 4. So when we think about this, n is really 20 times 4, because you're going to make payments 4 times a year for 20 years. So n is really 80. Now, if you look at that, that's identical to the other formula that we use with regards to where, and you'll see when I plug this in. So if that's the case and I go to plug this in, we should get something that looks like this. Our future value is 500 times the quantity 1 plus 0.0788 all over 4 raised to the 80 minus 1 all over 0.0788 divided by 4. Okay? So this is an annuity, and this is her plan. She's going to save $500 a month, $500 every 3 months, 4 times a year. So she's going to deposit about $2,000 a year into a checking account. Not 2,000, yeah, 2,000, right? How much will that be worth after 20 years? And this is how they compound that value. Okay. So now I got to plug it in the calculator. Now you can do all of this at one time in the calculator, but it's a little tricky. The 500 goes in the top. So I'm going to start a parentheses. I'm going to start a parentheses. This is the numerator of my fraction. So I've got 500 times, in parentheses, 1 plus, in parentheses, 0.0788 divided by 4. Close parentheses, raised to the 80 minus 1. That's the numerator. You guys should have your calculators out and plug this along with me. Divided by, on the bottom, this is the denominator, open parentheses, 0.0788, divided by 4, close parentheses, boom. That's the answer. Oh, you know what? Somewhere Mr. Adams screwed up.
I think it should be 0.0788.
Did I forget a?
Does that matter?
No. I think I forgot. I don't think you can put the 500 in there because I think it does it differently. So if I go delete, 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 delete. So that's in parentheses. That's get. Yeah. You can't put the 500. The fraction has to be calculated first, so you can't put the 500 in the numerator in the top like that. You have to multiply it by everything else. Okay? So that's Mr. Adams' mistake. That's the right answer. So don't multiply the 500 in all at once. Yeah, because when I put it in the parentheses in the top of the thing, yeah, that's not correct. So anyways, at the end of 20 years, $500 every 3 months will be worth $95,000. Okay? Any questions? Now, what would that be if she did? Now, look at this. That's $2,000 a year times 20 years. So she's really only paid $40,000. So when people make retirement accounts and stuff like that, that's what they're doing. They're putting that money in there, earning interest on it, earning a lot of interest, because she made about $55,000 in interest over the course of 20 years. Does that make sense? Okay, good.